Yeah, I think yeah, we can probably start. Yeah, hope this session can be valuable to the audience here. Yeah. So I'm Jamie from Lenalo. So I will talk about the convergence of big data and AI in this session. So as you know, big data is a field to deal with large or complex data sets, including unstructured, structured, or even semi-structured data. So it can be divided into mainly two parts, data analytics and data science. Data analytics focuses on the processing and performing statistical analysis on existing data sets, while data science focuses on unearthing some answers to the things you don't know. So there are multiple big data frameworks in the market, right? Most of them are under the Apache Software Foundation, like Hadoop, Spark, Flink, Kafka, Storm, and some other frameworks. So on the other hand, with the rising of deep learning technologies, AI is a hot topic in the recent years. So deep learning is a subset of machine learning, while machine learning is a subset of artificial intelligence. Right. There are some popular AI frameworks in the market as well, like TensorFlow, PyTorch, MXNet, right? And there are also some other machine learning frameworks like XGBoost, right? Like LightGBM from Microsoft, right? So for deep learning, the large data availability is one of the three key elements for the success of deep learning, right? So big data can provide the data required by AI learning, right? So on the other hand, for big data frameworks, if you want to do data analytics and data science, you also need some advanced algorithms, right? Which can be trained through the AI frameworks. So previously, we need one cluster for big data work, right? And we need another cluster for AI-related training, right? But there is a trend to unify these two clusters into one single cluster, so that a single cluster can be used for big data and AI. Okay, so in the industry, actually there are already some great effort to integrate machine learning and deep learning with big data. As you know, so Hadoop and Spark are some popular frameworks or projects under the Apache Software Foundation. So as part of the Apache ecosystem, there are already some work, or maybe there are already some components to support machine learning with some big data frameworks, like Mahout. Mahout was originated in Hadoop project to support the MapReduce execution engine. But now, it mainly runs on top of Spark and maybe some other framework. So Spark machine learning library is an important component in the Spark ecosystem for machine learning. Submarine is quite new, so it is a new project in Apache ecosystem to run machine learning on top of the resource manager directly, like Yarn, right? So for Flink, there is also a component called Flink ML, right, for machine learning support. And from industry vendors side, there are also some great effort, right? Like Yahoo provides Cafe on Spark, TensorFlow on Spark, right? So Uber has the Hollywood distributed machine learning framework, which is a Linux Foundation project now. From Microsoft side, they have the MML Spark, Microsoft Machine Learning on Spark. And there are also some third-party solution providers, like Databricks, right? They provide the deep learning pipelines module to support deep learning on top of Spark, right? They also have the machine learning flow to manage the life cycle of a machine learning. And there are also sparkling water from H2O, right, to support the H2O framework on top of Spark, right? So, and there is another one called HopsML from the logical clocks company. It is also quite new, but it is very maybe popular framework in the industry. Okay, so and from chip vendor side, actually, the bigger chip vendors are also providing their own integration, like Big DL from Intel, right? It is to support deep learning workloads on top of Spark. And from NVIDIA, they have Rapids, right? These are all some great effort to integrate deep learning with big data. And these chip vendors provide some hardware-specific optimizations on top of these frameworks. Okay, so from the previous page, we can see that those machine learning, deep learning integration are mainly based on Spark. So what is Spark? So I think most of people here know Spark already. So Spark is a unified analytics engine for large-scale data processing. So they have the Spark Core computing engine. It can run on top of resource managers like Hadoop, Yarn, Mesos, AWS EC2, Kubernetes, and you can also run it on top of the standalone resource manager as part of the Spark ecosystem, right? And Spark also provides some service modules, right, to support different workloads like Spark SQL, right, to support the SQL querying and related work, right? There is also Spark streaming, right? And the machine learning library is specific for machine learning support on top of Spark, right? There is also GraphX to support the graph visualization. So there are multiple languages can be supported in the Spark ecosystems, like Scala, Java, Python, R, SQL, right? So, and there are multiple options for storage and data sources. HDFS is supported, HBase, Hive, Cassandra, right? And some other storage options. Okay, so for machine learning library, the machine learning pipelines are defined to provide a set of APIs built on top of data frames from Spark SQL. So transformer, I want to describe some concepts in this machine learning pipelines first. Transformer is an algorithm to transfer one data frame into another. Estimator is an algorithm to be fit on a data frame to produce a transformer. While pipeline trains multiple transformers and estimators to specify a machine learning workflow, right? So we can see that if you input a data frame, you can use a pipeline to train the estimator and then generate a pipeline model, right? Then the trained pipeline model can be used for deployments, right? And then after you import a data frame, you can get the result for prediction. In machine learning library, there are already some support for popular machine learning algorithms. Like, there are several categories like classification and regression, right? So I think if you are familiar with machine learning, I think the algorithms here are very famous, right? Logistic regression, decision tree, right? Random forest, right? Gradient boosted tree, right? So all these famous classical machine learning algorithms are supported by machine learning library, right? And clustering, right? There is k-means support. There is a latent dirichlet allocation support, right? So yes, there are some also collaborative filtering, frequent pattern mining. So we can see that these are actually some classical machine learning algorithms, but not deep learning, right? How we can have deep learning support with big data, right? So because there are a lot of progress in recent years about deep learning, how we can have the deep learning results or maybe output be used with big data. Just as I mentioned in previous slide, so Databricks have a module called deep learning pipelines. So deep learning pipelines is built on Spark machine learning pipelines. So deep learning pipelines provide several key features for training and deployments with Spark, right? The images can be loaded into a frame and decoded automatically. You can enable fast transfer learning with featureizer to reuse pre-trained models. Take a deep image featureizer, for example. You can strip out the last layer of the model and replace it with a logistic regression transformer in the machine learning pipeline. And then you can train a new model based on the original deep learning model. This is called transfer learning, right? So there is also some great distributed hyperparameter tuning with estimator and the machine learning library built-in tools like cross-validator and the train validation split. For deployments, you can apply pre-trained deep learning models as transformers. Currently, TensorFlow-backed Keras models and TensorFlow graphs are supported. And you can deploy models with Spark data frames and even SQL user-defined functions. So it will be very convenient for the Spark developers to call these deep learning functions or deep learning algorithms directly. So I think this is very helpful and easy for original Spark developer to integrate the deep learning. There is another initiative from Databricks called Project Hydrogen. So it is an initiative to unify the big data and AI workloads. For this initiative, there are mainly three features. One is called barrier execution mode. So it was introduced in Spark to run distributed DL job, deep learning job, as Spark job with GAN scheduling. So specifically for Holloword, so you can use Holloword runner or Holloword.Spark to run Holloword as a Spark job. And another important feature is optimized data exchange between Spark and deep learning frameworks. So you can use the Pandas UDF implementation via Apache Allo. And from hardware perspective, the accelerator-aware scheduling was introduced in Spark via this initiative, right? In this case, you can have a heterogeneous accelerator support in resource managers like Yarn, Mesos, and Kubernetes. As you may know, for AI, so the NVIDIA GPU is very popular. They provide a very good support via the CUDA and the TensorRT frameworks, right? So with this heterogeneous accelerator support, so you can use NVIDIA GPU in the big data frameworks. It can be very helpful to speed up the data analytics and the data science related effort. Okay, so next I will talk about a little bit about distributed deep learning. Since distributed support is very critical to integrate deep learning frameworks with Spark or maybe some other big data frameworks. There are mainly two kinds of parallelism mechanisms for deep learning. One is called data parallelism. Right? We can also call it between graph replication. So there are synchronous and asynchronous training, right? So for synchronous training, there can also be centralized or decentralized mode, right? The typical algorithms for centralized mode is a parameter server. You can use one or maybe multiple parameter servers to save the parameters. And for decentralized mode, the ring or reduce algorithms is very popular. In this case, you don't need any additional servers. The parameter server can also be used for asynchronous training, not just synchronous training. Besides data parallelism, there is another mechanism, model parallelism. It is also called in-graph replication. But in big data world, this parallelism is seldom used because it is not aligned with the nature of big data. So from hardware perspective, right, to support distributed deep learning, we needed to have good support for multi-device and multi-node communication. Right? There are multiple options for interconnect technologies. Right? For example, the basic PCIe support, we have PCIe 4.0, right, which is the latest PCIe version. For NVIDIA, they have NVLink. For AMD, they have the XGMI based on Infinity Fabric. Right? And from Mellanox, they have the infinite band support, right? So in Intel, they have OmniPath, right? So there are also some other options, high-speed Ethernet, or maybe RDMA support over converged Ethernet. So I think the interconnect is very important. And for example, for the Fugaku HPC, just as Mr. Masuka-san shared this morning, so they also have their own interconnect technology called TOF. It is very important to have some great bandwidth, right? Accordingly, there are some libraries to support these interconnect technologies, right? For example, OpenMPI, it is a very famous open source implementation. NCCL is from NVIDIA, right? From AMD, they have a similar implementation called Rico, right? Radian to support the log-m software stack. There are also some implementations like Label Fabric from Open Fabrics, right? And UCX, right? Okay, so next, after some basic introduction about distributed deep learning, let's have a look the distributed support for machine learning and deep learning frameworks. So we can see that the blue lines are using the parameter server algorithms, while the green lines are using the ring or reduce based algorithms. So there are, just as I mentioned, there are multiple deep learning frameworks like TensorFlow, PyTorch, MXNet, Keras. And accordingly, there are some distributed machine learning frameworks in the market, or maybe which have very good support on big data frameworks like Spark. Holloword is one of them, right? TensorFlow on Spark maybe is some kind of little old, right? So, and some new like Hops ML and Angel ML, right? So TensorFlow has several distributed mechanisms, or maybe distributed strategies. One is parameter server. This is a very basic algorithm. They also have MPI collectives for Baidu or reduce mechanism. And another one is collective or reduce strategy. So for Holloword replaces the Baidu or reduce algorithms with the NCCL implementation from NVIDIA. For Hops ML, they already integrated the collective or reduce strategy from TensorFlow in recent versions. So Holloword Estimator is a Holloword integration with a Spark machine learning library for distributed training. And for Keras, with a TensorFlow backend, it can also be supported by Holloword or maybe Hops ML. Talking about PyTorch, it can be supported by Angel ML via the parameter server. And it can be supported by Holloword via the ring or reduce algorithm. From MXNet side, it can also be supported by Holloword via the ring or reduce algorithms. So I didn't list all the configuration here, right? So I think maybe different companies or different vendors have their own thinking about this. Maybe they are familiar with some of the frameworks, so they can configure the distributed cluster based on their requirements, right? So here, I just want to list some of the major or maybe popular configurations used by the industry, right? And all these are open source. Of course, some big players in the industry have their own proprietary solutions. Okay, so I think previous introductions is some common technologies for all hardware platforms, not specific for ARM, right? Then how about the ARM story? What's the status now, right? So in Linalo side, we have a group called the Linalo Data Center and a Cloud Group. So we have a big data leader project, right? So to handle big data support on ARM server platforms. We enable the components of, for example, the Spark components, right? Hadoop components, and we also do some optimizations on ARM server platforms. We also have a high-performance computer special interest group. We are doing some SVE support, right? This can be helpful to, from performance perspective, right? We are also working on MPI library, like OpenMPI, for a HPC cluster, right? We are also doing some optimizations for math libraries like OpenPlus, right? FFT, right? Specific for ARM64 platforms. So this is one group related to the work I'm talking about here. Another group is a Lenovo Machine Intelligence group. So the initial focus is on inference support with Cortex-A chips. And we are working on ARM neural networks, TVM, right? And we also have some discussions about training support on ARM server platforms jointly with the LDCG group, right? So because to enable big data and AI unification, the training support on ARM server platforms is a must, right? So, and to have maybe good performance of AI training, I think the CPU sometimes is not enough, right? We may probably need to have some accelerator support in this space. The most popular solution in the market now is using NVIDIA GPU, right? And we are also working with Recon and Fujitsu on SVE, right, to support accelerated training, right? So from GPU perspective, so NVIDIA announced at the ISC19 that they are going to support NVIDIA AI and HPC stack for ARM HPC by end of this year. So I think this can be helpful to lift the major barrier to integrate or maybe enable AI solutions with big data on ARM platforms, right? So what can we do next, right? We can see that comparing to x86 platforms, we do have some gaps there, right? So we are, from Lenovo perspective, we are working closely with ARM and some other members to see how we can reduce the gaps, right? So how, for example, how to enable training support on ARM server platforms, right? Because, you know, ARM servers can be important, right? Especially in HPC world so far, right? So this is one important area we are looking at seriously. Okay, I think that's all for my presentation today. I'm not sure if there's some time for questions. No? Okay. Thank you, everybody.